The law of cosines, or also known as the cosine law, is a formula where you can compute the length of one side if you know the length of two other sides and the opposite angle. Now, rather than trying to show you the proof, because the proof of the cosine law often doesn't give you anything, it doesn't give you any insights into why this law does work, I want to separate these into several parts and try to elaborate why the cosine law has to be this formula. The first thing I want to show you is that the graph of the cosine, y equals to cosine x, if you draw it from 0 degrees to 180 degrees, it's a function that starts from 1 and ends at -1, and it's always decreasing. Now, why is that important? That's because, think about this. You have the cosine and there's a minus. That means the minus cosine, or minus something times the cosine, these are positive numbers, so minus something times cosine will be an increasing function. So the law of cosines, even without knowing what this would do, you would already see that as you increase the angle C, the length of the side C would be increasing. Now, to observe why this is true, all you have to do is fix the length of B and fix the length of A and try to just increase the angle C. Now, if you do that, you're going to get, as you can see, I'm fixing this length, but only increasing this angle C. And what's happening? As you increase, the length C increases, right? So that's why you need this minus, so that when minus cosine C is computed, it will be an increasing function. Now then, I want to explain why you would need the a squared plus b squared. Well, if you go back to the cosine graph hits 0 exactly at 90 degrees. So when you increase this angle to become 90 degrees, let's say this is the 90 degrees, and then the cosine of 90 degrees will become 0. So what you end up with is c squared equal to a squared plus b squared minus 2ab times 0. So that's nothing. What are you left with? You get the Pythagorean theorem, right? In other words, you see that the law of cosine is an extension of the Pythagorean principle. So the Pythagorean theorem works only for right triangles, but for any triangle, if you use the cosine, you can figure out the other length by using the cosine law. That's what's so cool about the law of cosines. All right, so from here to there, I even increased more, and now I have to explain why you need this 2ab. Well, think about this. What would happen if you increase the angle C even more so that it eventually becomes this very flat triangle? So at the limit, when you actually end up with just angle C being 180 degrees, if this angle C is 180 degrees, and this length is A and that length is B, then what you end up with is you get this flat line as C, and the relationship between C and A would be like this. C equals to A plus B. Now, what does this mean? It means that this cosine law better give us this relation if you have C equal, the capital C, this angle C equals to 180 degrees. Well, back to the cosine graph, what happens at 180 degrees? Cosine of 180 degrees is -1. So when C is equal to 180 degrees, this is the equation you get. You get C squared equals to A squared plus B squared minus 2ab times cosine of 180 degrees. That's what we're doing. C is 180. But this is -1, so you end up with C squared equal to A squared plus B squared minus 2ab times -1. But -1 times negative is positive, so you have C squared equal to A squared plus B squared plus 2ab. It doesn't look like the right side a priori, but then you remember this looks something very familiar. Then you remember that, oh, this is really a plus b squared, isn't it? So c squared equal to a plus b squared, and then if you take the square root of both sides, given that c and a and b are all positive, you do get c equals to a plus b. So the reason that you have this 2ab is so that when you end up with 180 degrees, you do get a squared plus b squared plus 2ab. This turns into plus 2ab, and the formula just means that if you have a straight line and you break it into two parts a and b, then the sum of a and b would be the length c, which connects these two opposite endpoints. That's all it's saying. So looking at these various examples, you now see why the cosine law has to be that way. So to recap, c squared equal to a squared plus b squared, that's the Pythagorean theorem. The minus is needed so that minus cosine will be an increasing function, because you observe that if angle c is increasing, the length c is increasing. And also you need this 2ab so that when cosine c becomes -1, you get a plus b squared. That's all.